M1, M2 are connected by light rod, and the system is slipping down a rough incline of inclination theta with horizontal. The coefficient of friction at both contact is mu. Find the acceleration of the system and the force by rod on one of the blocks. Okay, so this question, first let us make the diagram. This is the incline. There are two objects. One object is here, another object here. Okay, and these two are connected by light rod. Light rod is connecting between them, and M1, M2. This angle is theta. Coefficient of friction is mu at both places. Okay, so we have to find reaction force. The reaction force developed at this place. So what we can do is, for that, first we need to find the acceleration of the system. So first, combined system. First we consider for M1 and M2 together, because they are joined, they cannot separate, so they will always move together. So we have to consider them together. If they are together, now what are the forces? So M1G plus M2G, then normal N1, normal N2, then friction F1 and friction F2. Okay, like this. This is X and this is Y. If you write equation along X, it will be M1G plus M2G sin 30 degree. Okay, sin theta. Sin theta. This is the angle of inclination of inclined theta. So M1 plus M2G sin theta. This is down the inclined force minus friction. So F1 minus F2 equal to A. So if we solve this, how much we have is acceleration will be equal to M1 plus M2 G sin theta, and friction will be mu M1 G cos theta, and both are having mu M2 G cos theta divided by, oh sorry, this is M1 plus M2, masses will also be there, divided by M1 plus M2. So M1 plus M2 is coming common everywhere. It will be G sin theta, and then M1 plus M2 is common, minus mu G cos theta divided by M1 plus M2. So these two are cancelled. We are having G sin theta minus mu cos theta. Okay, so this is the value of acceleration. Now we have to find the internal force between these two. So for that we need to consider the separate objects. So we consider, suppose for M1, for object M1, what are the forces? So for M1, this is M1G, this is normal, then there is a friction, and then can be reaction force. So suppose we consider the reaction force like this. We do not know on which direction it will act, whether it will pull the object or push the object, we do not know. So we are taking any arbitrary direction. And if you write the equation, we have to write M1A equal to M1G sin theta down the incline minus friction F1 minus reaction force, okay, or M1G sin theta, F1 will be mu M1G cos theta minus R. Okay, now what is the value of A? A we have got. So if you put the value of A here, G sin theta minus mu cos theta, the value of A we have calculated. Now this side is again G M1 sin theta minus mu cos theta minus R. So you can see these two are same, they can be cancelled. So R which we are getting is 0. So the reaction force we are getting in this case is 0. And why we are getting 0 is, the reason behind this, if you see, these two are having same coefficient of friction. These two objects are having same coefficient of friction. So none of the object will slide faster and none of object will slide slower. They are trying to slide together. So there is no reaction force developed between them. If suppose the lower object would have smoother surface, suppose the mu for lower surface was less compared to the upper object, then this object will tend to slide faster, and in that case the reaction force will be what? Pulling the two objects. The reaction force will develop in such a way that it will pull the two objects. And it's just opposite to that. If the coefficient of friction on the lower object is larger, then it will tend to slide slower and the upper object will tend to slide faster. In that case, there will be compression developed in the rod. If this one is having the lesser, more friction, if this one is having more friction, the lower one is having more friction, the upper one will tend to slide faster. So they will try to compress the rod. In that case, compressive force will develop. Okay, then they will push each other. And if the lower one is having lesser friction, then they will develop the tensile stress. They will develop tension. They will try to pull each other. And if they are having same friction coefficient, they are trying to slide with acceleration and no reaction force is developed. Okay, this is occurring because both M1 and M2 have equal smoothness. So because of this we are getting this result.